You are tuned to Iri-e-learning and I am your host, Teacher. In this States of Matter lesson, we will examine sublimation and deposition. Check the description box for links to all the lessons for this unit. By the end of this lesson, we should be able to explain the process of sublimation and deposition in terms of energy changes and particle arrangement. It's experiment time, and the aim is to observe sublimation and deposition of iodine. Materials needed for this experiment: iodine solid, a hot plate or another heat source, beaker, round bottom flask or evaporating dish. Sometimes you can use a watch glass, and ice, whether cubes or crushed ice. We will use a diagram to illustrate the experimental setup for the procedure. We have a hot plate on which we'll place a beaker. Inside the beaker, we'll place some iodine solid. On top of the beaker, we'll have our round bottom flask containing ice, and it can be ice cubes or crushed ice. Once we have our experiment set up, then we will turn on the hot plate to increase the heat energy to the iodine solid. This experiment is usually demonstrated in a fume hood or well-ventilated room because iodine vapor is highly toxic and a severe irritant to the eyes and respiratory tract. It's time to record our observations, but before we do so, here are some questions to guide us in the process. 1. Describe the iodine solid at room temperature. 2. What happened when the iodine crystals were heated? 3. What is the color of the iodine gas? 4. What happened when the iodine gas came in contact with the cold glass? Let us start by describing iodine solid as it appears at room temperature. At room temperature, we can see that iodine is a solid. It is black in color and it has a shiny appearance. Although iodine solid has a shiny metallic appearance, please note that iodine is not a metal but a non-metal element. A few pellets of iodine solid are placed in the beaker. Heat energy is supplied to the iodine solid, and note that the solid changes directly into a purple or violet colored vapor. As the vapor rises, it hits against the cold surface of the round bottom flask. As the violet vapor touches the cold surface of the round bottom flask, many black, shiny, needle-like crystals are deposited on the cold surface. Here is a sample observation. The iodine was a shiny black solid at room temperature. The iodine solid changed directly into a violet gas or vapor as the temperature increased. Many black needle-like crystals were deposited on the cold surface of the round bottom flask as the violet vapor made contact. You are reminded not to reproduce this sample document for any class assignment. Next is the analysis and interpretation. Let us review a few discussion questions to guide us in this activity. Question 1. Why was the hot plate used in the experiment? The hot plate was a heat source, and the heat energy supplied by the hot plate increases the energy of the iodine molecules. Question 2. Why was ice used in the experiment? Ice was used to cool down or remove heat energy from the gaseous iodine molecules. Question 3. Identify the two change of state processes that occurred during the experiment. The first process that led to a change of state was sublimation. Sublimation occurred when the solid iodine changed directly into the violet vapor when heat energy was supplied. And the second process that resulted in a change of state was deposition, which occurred when the violet vapor was cooled and changed directly into a solid. Question 4. Explain the two change of state processes in terms of energy, interparticle forces, and particle arrangement. As the solid iodine particles are heated, they gain more energy and vibrate vigorously. The iodine molecules or particles gain enough energy to break the interparticle forces between individual iodine molecules. The individual iodine molecules separate from each other into the gas state. This, of course, is called sublimation, where the solid changes directly into a gas when heat is supplied. Continuing with question 4, as we know that the iodine particles are now in the gas state. When the iodine gas makes contact with a cold surface, as in the RB flask, the molecules lose energy. The particles begin to move slower and closer together. The interparticle forces increase between the iodine molecules, holding them together in a fixed position. The iodine particles no longer move around. They can only vibrate in a fixed position within the solid state. This is deposition, where a gas changes directly into a solid when cooled. So instead of providing a sample discussion, we're giving you the opportunity to write a discussion of your own. You can always share what you have written in the comment section, and we'll be happy to respond or reply to you. Let us go through the lesson summary points. Iodine is a black shiny solid at room temperature. Iodine solid changes directly to a gas when heated. This is sublimation. Iodine molecules, I2, vibrate in a fixed position in the solid state. When solid iodine is heated, the interparticle forces between the iodine molecules, I2, break. The molecules move apart and enter the gas state. Iodine vapor, or gas, has a violet color. Iodine vapor changes directly to a solid when cooled. This is deposition. The gaseous iodine molecules, I2, move fast and randomly. When gaseous iodine molecules, those are the I2 molecules, are cooled, they move slower and closer together. The interparticle forces increase between the molecules, holding them together in a fixed position within the solid state. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Identify the statement that best describes the physical appearance of iodine at room temperature. A. Iodine is a violet vapor at room temperature. B. Iodine is a black vapor at room temperature. C. Iodine is a shiny violet solid at room temperature. D. Iodine is a shiny black solid at room temperature. The answer is D. Iodine is a shiny black solid at room temperature. Question 2. Which statement best describes the changes in particle arrangement when iodine solid is heated? A. The bonds within the closely packed iodine molecules break and the individual atoms separate and move apart. B. The interparticle forces between the closely packed iodine molecules break and the individual molecules separate and move far apart. C. The interparticle forces between the closely packed iodine molecules break and separate into clusters of molecules. D. There are no changes in the particle arrangement. The answer is B. When iodine solid is heated, the interparticle forces between the closely packed iodine molecules break and the individual molecules, those are the I2 molecules, separate and move apart. Note that it's not the covalent bonds within the I2 molecules that break, but rather the weak interparticle forces between the I2 molecules. Question 3. Which statement best describes the changes in particle movement and arrangement when iodine vapor is cooled? A. The freely moving iodine molecules lose energy and move slower and closer together, allowing the interparticle forces to hold them together in a fixed position. B. The freely moving iodine atoms lose energy and some atoms form clusters that move past each other. C. The iodine molecules lose energy, move slower, and remain far apart. D. There are no changes in the particle arrangement. The answer is A. When iodine vapor is cooled, the freely moving iodine molecules lose energy and move slower and closer together, allowing the interparticle forces to hold them together in a fixed position. Question 4. What process occurs when iodine vapors change directly into the solid when cooled? A. Freezing. B. Sublimation. C. Deposition. D. Condensation. The answer is C. Deposition is when the vapor changes directly to the solid when cooled. Question 5. What process occurs when iodine solid changes directly into the vapor when heated? A. Evaporation. B. Sublimation. C. Deposition. D. Melting. The answer is B, sublimation, which occurs when the solid changes directly into the vapor when heated. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you'll receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.